Hello everyone, my name is Aditya and this is my first lecture on number system. Number system is a very important chapter in quantitative amplitude for CAD, ZAD or other management examination. So today we are going to explore basics of factors. So let's define what is factors. So factors are all the natural numbers that are equal to n or less than n that divides n. Okay, let's take an example. For example, uh 20, right? Let's take an example of 20. So 1 is divisible by 20, 2 is divisible by 20, 4 is divisible by 20, then uh 5 is divisible by 20, 10 is divisible by 20, and 20 is divisible by 20, right? So let's count how many factors are there. So this number, the numbers which are in bracket, they are the factors of 20. So 1 2 3 4 5 6, 6 factors, right? Same way, let's take an example of 36. Okay, 36, a random number. So 36, 1. So like 1 is the factor, then 2 is the like factor as it divides 36, then 4 as 3 as well, then 4, then 6, right, 9, 12 as well, 18, yeah, and 36. So yeah, uh this number, the numbers which are in the bracket, they are the factors. So let's count: 1 2 3 4 5 6 7 8 9. So 9 factor in total, right? Factors mean like the numbers that divides 36. Okay, and for the note this, like 1 is always a factor of every number. It like it divides every number. Actually, it divides every number. It also multiplies with every number, multiplies with every number. Okay, it's a very selective number. So now, uh let's take an example of 2 cube. Okay, 2 cube, 2 cube, so 2 raised to power 3. So it can be written in the form 2 multiplied by 2 multiplied by 2, right? So 2 multiplied by 2 multiplied by 2, so it's 8. And 8, it is divisible by 1, it is divisible by 2, it's divisible by 4, and it's divisible by 8. Okay, 1 2 3 4, 1 2 3 4. So the fact so 1 2 3 4, the total factors of 8 is 4, right? So but like as it was like shorter number in value, so it was easy to divide, to find the remainder by this way. But what if the numbers are bigger in value, like 3 6 2 4, or 1 0 0 1 0 1? So in this case, what to do? Yeah, so we can't rely on this method. So we'll see a new topic, we'll see a new concept. Okay, so let's take an example of 36. 36, yeah. So like uh break down this 36 into prime numbers. Like we have to find the prime numbers. But actually, don't break this like, don't break the 36 like this, like 2, then it's uh 18, like 2, then it's 9, then 3. Don't do like that. For amplitude examination, we have to be quick. So break 36 in a way like you can break it like 4 multiplied by 9, right? Break this in a way, in a way such that you are able to like comfortable with that number. So like 4 multiplied by 9, I am comfortable with that. So 4, so 4 number, so like 4 is like 2 multiplied by 2, right? 2 square. And 9 is like 3 multiplied by 3, which is 3 square. Okay, so the prime factors of 36 are 2 raised to power 2 multiplied by 3 raised to power 2. All right. So 2 raised to power 2 into 3 raised to power 2. So like if you see, so 2 raised to power 2. So 2 raised to power 2 can be written in the form of, like can be written in the form of 2 raised to power 0 multiplied by 2 raised to power 1 multiplied by 2 raised to power 2 up to the exponential power. Okay. Same way 3, same way 3 raised to power 3 raised to power 2, yeah, 3 square. So 3 square can be written in the form of 3 raised to power 0 multiplied by 3 raised to power 1 multiplied by 3 raised to power 2. Okay, yeah, right. If you see additional one digit like 3 raised to power 0, the answer is 1, but this one term is added in addition, and this one also, this is added. Okay, like this was 2, but if you, what do we say, if you expand this, this will be 2 multiplied by 2 raised to power 0 multiplied by 2 raised to power 1 multiplied by 2 raised to power 2, right? So one value gets added, right? So the total terms, so the total terms are 1 2 3 3, right? And 1 2 3 3. So if you multiply this both 3 3, the result would be 9 factors. Okay, and same answer was for 36, which was 9 factor. Okay, see the answer, 9 and 9. So we got the answer. So same way we'll try to break any other number, like in the same way we'll try in the same topic, like for the same concept we'll try to break this number to find this factor. Okay, so 144 can be written as, first of all we have to uh, first we have to break down the prime factor of 144. So don't like, we can do like that 144 then 2 then so on, but it's very time consuming, and in amplitude examination we have very less time. So we'll just break down this number into such number that we are comfortable with, like 16 multiplied by 9. Okay, it can be written in the 16 multiplied by 9. Okay, so 16 multiplied by 9. Okay, so 16 can be written in the form of 2 multiplied by 4. Yeah, 16 can be written in the form of 2 multiplied by 4, and 3 can be written in the for 3 can be written in the form 3 raised to 3, right? So if you see this 2 raised to power 4, it can be written in the form of 2 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. Okay, same way this 3 can also be written in the form of 3 cube can be written in the form of 3 raised to power 0 multiplied by 3 raised to power 1 multiplied by 3 raised to power 2 multiplied by 3 raised to power 3, right? This can be written in the form of this way, and this also. Okay, so as it can be written in the form of 3 raised to power 0, 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, right? See, it can be written in the form of this. I will just erase this part. Okay, now as you can see, this is 2's bracket and this is 3's bracket, but now see, this is a multiplication, so this single term will multiply to hold the bracket of 3, right? like this will multiply to this will multiply 2 raised to power 0 will multiply to 3 raised to power 1, this will multiply to 3 raised to power 2, and so on. And this single value will multiply to this, then this single value will multiply to the whole bracket of 3, right? And this single value will multiply whole value to this bracket as well. So uh, we'll just write down uh, the terms into bracket, which is 1 2 3 4, like 2 raised to power 4, no, 2 raised to power 2 raised to power 4 multiply by 3 raised to power 3. Okay, and this is the number, like broken number into its factors, and it should be prime factor. Okay, this should be prime factor, right? Now see, 2 raised to power 4 and 3. Okay, this is 1 2 3 4, 1 2 3. So if we do what, it's 1 2 3 4 5, actually, sorry, I just missed one number. So 5 multiply by 1 2 1 2 3. Okay, 1 2 3 4, 0 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, 1 2 3 4, yeah, 4 value. So the answer would be 20F. So see, from 144 and from 36, you can observe that you can observe that uh, it's like addition to the exponential power. Okay, you can observe that one is added. Why one is added? Because this term is uh, added to, like, it this was like diminished in itself, like not diminished, actually it was like hidden in the 2 raised to power 4. Like see, 2 raised to power, it was 4, no, so it was like 2 raised to power 0 multiply by 2 raised to power 1 multiply by 2 raised to power 2 multiply by 2 raised to power 3 multiply by 2 raised to power 4. It was like that. See, like for like 2 raised to power 4, this is the expanded form, this is the expanded form. Okay, so 2 raised to power 0 is actually 1, so there is no effect in the overall LHS. Yeah, so that's why 1 was added due to the addition of 2 raised to power 0 term. So we'll just drop this. So yeah, as like I was saying, you can observe that 1 is added to the exponential power and it's multiplied to the corresponding of that. So let's take the example, like a natural number n is there, which can be written in the form, which can be written in a form p p1 raised to power a uh, into p2 raised to power b multiply by p3 raised to power c. Okay, and so on, where p is a prime number. Okay, p is a prime number. So if, as you can see, now it's a prime number and in exponential, and is it's have exponential power, so it can be written in the form as, it can be broken down into form as p1 raised to power 0, p1 raised to power 1, p1 raised to power 2, p1 raised to power 3, so on till the p raised to power p1 raised to power 8. Yeah, same with p2, p2 raised to power 0, p2 raised to power 1, p2 raised to power 2, so on till p2 raised to power b. Same way goes with this one. Okay, this p3 raised to power 0 till the value where we get 3 3 raised to power c. Okay, so as you can see, here we can write as a plus 1, right? A plus 1, because this is a and one term is added. there it can be written as uh, b plus 1 actually, because b exponent and one term was added. Okay, and uh, pc c plus 1. Okay, because pc and 1 was added. So okay, now uh, now like this is the term of a, right? This is the term of b and this is the term of c. So from here we can derive one formula, which is a plus 1 into b plus 1 into c plus 1, and so on, like till the prime number is mentioned. So 1, b and c, if you can see, they are the exponential power, right? They're exponential power. So this, from this we can uh, find a total number of factors in any number. We don't require to write this all. This was for the explanation factor, but this for the explanation the concept, but this will try to write all the concept. Will not try, actually we have to do in this way only. So like just is, and we'll do. And now I'll give you some important numbers, like a specific number for a specific factor. Okay, so like remember that. 2 minutes, let me rough this. Yeah, okay, now I will give you a specific numbers and their exponential power. Just remember that. Some topics to remember. Okay, there are some topics to remember. Okay, some topics to remember. All right, yeah. See, number like 1024, 1024, 1024 can be written in the form 2 raised to power 10. Learn it, huh? Learn it. This is like in the further classes, uh, this number are like frequently asked, so learn it. Okay, 1024 can be written in the form of 2 raised to power 10. Then there is a number 999. Actually not a number, any number which can be which are written in the form of a. Okay, so they are the multiple of 37. 37, okay, 37k actually, 37k. They are the multiples of 37k, so they can divide 37 as a whole. So for 999, it can be as it's a one digit, like one digit plus one digit plus one digit, like a same digit, like the three have a same digits. So it can be like written as 37. Okay, so if we divide it by 999, we get a value as 27. Okay, so like 37 is a prime number, like it has only two factors, like 37 is a prime number, and 27 can be written in the form of 3 cube, right? So like it has 37, like it don't like we don't do this. It's actually better not to expand it because it can't, like, only there are only two factors, no? So like 1 and the number itself, which is 37. So see 3. So like, so see the two factors, okay? These are two factors, like 1 and 37 itself, and like, and this is like 3 raised to power 0, 3 raised to power 1, 3 raised to power 2. Okay, if we 1 2 3, okay, 3 and this 2, so like 2 plus 1 and 2 plus 1 and 3, like 3 and like, no, actually it's 1 and 3 plus, and this is 3, no, 3. So 1 and 3 is equals to uh, 8. Like say 2 factor plus 1, so 3 to 3. Something wrong happened actually, sorry from my side. See 37, no? So 37 multiplied by 3 cube. So the uh so the see, this is 1, like 1 and 37, and this is 3 cube. So 3 cube, so 3 raised to power 0 plus 3 raised to power 1, 3 raised to power 2, 3 raised to power 3. If we do this like this way, this a plus 1 and then b plus 1, like a plus 1, like a raised to power 1 is there, so 1, so like 2, like by this formula, 2 comes, like 2 multiplied by 3, so 4. So like 3 plus 1, right? So 4, which is like 8 factors, right? Yeah, let's rough it. Uh, let's rough this. Then I will give some more numbers to remember. More topics. Yeah. So as we have done that, A, the multiple is 37k. Okay, note this, and this is also important. Then we like the thing which I am giving you to learn, they are very important, and we are going to discuss them in the further lectures, so please note them and learn them thoroughly. Then third third topic, yeah, number two, third topic to remember is 1001. Okay, see, it seems like it's a prime number, but actually it's not a prime number. 1001, it can be broken down into 7 multiplied by 11 multiplied by 13, which is a consecutive 3 prime numbers. Okay, right, they're consecutive 3 prime numbers. So 1 1 1, so 1, so by the formula a plus 1, b plus 1, and c plus 1, right? this can be written as 2 multiply by 2 multiply by 2, which is 2 cube, which is 8 actually, 8 factor, right? Okay, this also remember thoroughly. Then, well, I will rub this all. Yeah, now learn this as well. See, 101001k, the 13k is the multiple of 100. Okay, 1001 is 13k, like it divides 13k completely. Okay, then 1001 is a multiple of 13k. Okay, then comes 1003, 1003k, it's a multiple of 7k, 17k. Then comes 1007k. Okay, 19k. Okay, so 19k is a 1007k is a multiple of 19k. Okay, then comes the 1009, 1009. Note that this is the first four digit prime number. Okay, first four digit prime number. Okay, right? Then learn this. This is like very important thing. Learn this. And now we'll do this one. Okay, 1003. So it can like we have discussed, like it is the multiple of 17k, so we can write 17k multiply by, if we divide this we'll get 15 59. Yeah, 59, we'll get 59. uh and furthermore, if we like see, 17 is a prime number, and uh 59 is a prime number as well. So by this, that 1 plus a and b plus 1, sorry, a plus 1 plus b plus 1, where b are the is the index. Okay, so index is like power and index are the same thing, so it's the same thing. A power and index is the same thing. So this 1 plus 1 multiply by 1 plus 1 actually, which is 2 multiply by 2, which is 4. So answer is 4 factor. So 1003 has 4 factors. Then if you yeah, you may ask then what is the first 5 digit prime number. So this is also important. So first 5 digit prime number is 10007. Okay, 1 2 3 4 5, right? This is the first 5 digit prime number. Okay, right? So learn and remember is the things which I have told. And uh, for the basics, this was way more than sufficient. So in the next class we'll discuss more concepts and more examples. For now, thank you for visiting.